I'm going to go over how to get the standard error for independent t-test, but before that, I'm going to go over an example of how to get the pooled standard deviation because you need that to find the standard error for an independent t-test. So here's our example problem. It says you are conducting an independent t-test to compare men and women on a performance test. If the standard deviation for men is 2 for a sample of 56, and the standard deviation for women is 8 for a sample of 28. What is the pooled standard deviation? Round to the second decimal place as needed. So from this problem, you can see that there's two groups that we're going to compare, men and women. And it says the standard deviation for men is 2, so you should probably write that down. And the sample size is 56 because it says for a sample of 56. So that's N for men. And then for women, we have a standard deviation of 8 and an N of 28. And if we have these 4 pieces of information, we can then get the pooled standard deviation. So here's the formula for the pooled standard deviation, and that's the S squared pool is the variance, the pooled variance, and you need to get that first, and then take the square root of it to get the pooled standard deviation. And the information that you need is the degrees of freedom for each group, its variance or its standard deviation for each group, and then the degrees of freedom total. That's all you need. You can see here that here is the variance for the first group, and this is the variance for the second group. So if the problem gives you the variance, then you just put the variance there and you don't square it. But if you get the standard deviation, then you have to square it to get the variance. So remember, S is the sample standard deviation, S squared is the sample variance. So keep that in mind. Also, kind of look at the formula and you can kind of see how this is a weighted average of the two sample standard deviations. So we have 2 standard deviation, but we just need 1 so we can get the standard error. So what we do is we use the degrees of freedom to find it, which is related to the ends, right? The sample sizes. So what this does is gives more weight to the one with the bigger degrees of freedom or the bigger sample size. So we're just averaging basically the 2 sample standard deviations, but giving more weight to the one with the larger sample size. Alright, now I'm going to show you how to fill in the formula for the pooled variance, and then later on I'm going to show you how to put it in your calculator or Excel to get the pooled variance and then the pooled standard deviation. I'm going to show you how to do Excel, which is also the way you do for a scientific calculator. And then I'll also show you how you'd have to do it using the order of operations in a basic calculator. First, let's fill in the formula. So S2P, so we're finding the pooled variance. Okay, and the degrees of freedom for the men was 55. And the degrees of freedom for the women was 27. The standard deviation for the men was 2, and the standard deviation for the woman was 8. So let's fill all that in. Oh, and then the degrees of freedom total was 82. So 55 is the degrees of freedom for the men, so I'm just going to make the men 1. So we're doing 55 times the men's standard deviation, which is 2. Now because we're given the standard deviation, we have to square this. Now if you're given the variance, then you would not have to square it. You just put 4 here. So if the problem said the variance, sample variance for men was 4, then you would just put 4 here and you wouldn't square the 4. So pay attention to that. This is S squared. So standard deviation is S. So S is standard deviation. And S squared is the variance. So let's keep that in mind. And the standard deviation squared is the variance. Okay? That's for both of these here. Alright. And add the degrees of freedom for women, which is 27, times the standard deviation for women, which is 8, and we need a square because that was the standard deviation and not the variance, and divided by 82. And then what I would do, just to help you out, if you're putting it in your calculator, either your scientific calculator or using the order of operations in a basic calculator, I would put parentheses on the top and the bottom. So these are kind of implied when you have a fraction sign like this. So that big long division sign means that really these are kind of in parentheses. The bottom doesn't really need to be in parentheses in this case because it's just one number, but if it had some other things going on in the bottom, then we would definitely need to have the parentheses there. But just so you know, it's kind of implied that the parentheses are there. And after you figure out this formula, then you take the square root of it to get the pooled standard deviation. So, right now I'm going to show you how to do it with a basic calculator. So if you don't have a scientific calculator or if you don't want to use Excel, but for this you have to remember your order of operations, which are P, E, M, D, A, S, and the M and the D go together, and the A and the S go together, and that stands for parentheses, exponents, multiplication, division, addition, and subtraction. So first we want to do what's within the parentheses, and we have two parentheses, but the 82 is already simplified all the way. Don't have to do anything with that. So we're going to focus on the top of the fraction here. And inside the parentheses, there's no other parentheses. So now we're going to do exponents. So that's going to be the 2 squared and the 8 squared. So we have 2 squared p equals 55 times 4, because that's 2 squared, 2 times 2, plus 27 times 8 squared, which is 8 times 8, which equals 64. Alright, and then divide that by 82 still. We don't have to worry about the parentheses there. Alright, and then the next thing you want to do is the multiplication and division. And there's only multiplication, and we're going to do it from left to right. So we have 55 times 4, which equals 220, plus 27 times 64, which is 1,728. And then we're going to divide that by 82 again. Then there's no division, and then addition and subtraction, and there's only one addition. So then we have 1,948 divided by 82. Now, once you do everything in the parentheses, once you do everything in the top and the bottom separately, then you can divide. And we'll get 23.76. But then we need to take the square root of that to get the pooled standard deviation. This 23.76 is the pooled variance. So if you take the square root of that, you'll get 4.87. And that's the pooled standard deviation. Alright, so you found the pooled standard deviation. That's a big part of it. But now you need to also find the standard error. So you need to know the difference between standard deviation and standard error. standard deviation is how far a typical individual is from the population mean. So standard deviation is about variability of individuals. The standard error, if you remember from the central limit theorem, is how far a typical sample mean is from the population mean. That is for a one sample mean test. But when you have an independent two sample t-test, then the standard error is about the variability and the difference between the sample means. So how much does that difference between the sample means vary from samples to samples? So in the middle of the distribution, when we calculate the p-value, we'll have a 0 in the middle for the population mean of differences, because a 0 means that there is no difference between the two means. So hopefully you at least know the basic difference between standard deviation and standard error. Standard deviation is about variability of individuals, and standard error is about variability in sample means, and it could be the difference between sample means, or it could just be one sample mean in case of one sample t-test. And for the two sample dependent t-test, then it's about the difference scores, the variability in the difference scores. So the standard deviation for the different types of t-test is a little different, but you should kind of see that they're basically almost the same. Well, not the same, but very similar, and it's way different than the standard deviation. Now here's the two formulas for the standard error for the independent t-test, and you can use either one. The first one uses the pooled standard deviation, and the second one uses the pooled variance. So you can use either one. I'm going to use the first one. So this is standard error for the difference between the two sample means. That's why we have the subscript here. And it's going to be the pooled standard deviation times the square root of 1 over the sample size for the first group, which is 56. Oh, excuse me, I'm sorry. Plus 1 over 28, which is the sample size for the women. And there you have your formula. And next I'm going to show you how to use Excel to calculate this, and then how to do it with a basic calculator. Okay, so we already found the pooled standard deviation here, which is 4.87, and now I want to find the standard error. So we're going to just use our calculations that we had already. And we're going to use that formula that was on the last slide. So you're going to put an equal sign and then 4, well, you don't have to put 4.87 because we already have it here. So you're going to just click on it, times, which is shift 8, the asterisk, and then put square root, SQRT, and then in parentheses, put 1 divided by, which is the forward slash, 56, plus 1 forward slash for division, 28, and then close your parentheses and press enter. And so the standard error is 1.128. Okay, now I'm going to find the standard error, which is a basic calculator, and you still need to remember your order of operations. So there's no parentheses, but there's an exponent, which is the square root sign. That's technically still an exponent. It's like something to the 1/2, basically. So we're going to do inside there first. And then inside there, you kind of start the order of operations over again, and there's no parentheses inside of it. There's no exponents inside of it, but there is division. So we're going to start with the division. So keep this here. Then inside we have 1 divided by 56, which is 0.0179 plus 1 divided by 28, which is 0.0357. Okay, so we did the multiplication and division. Well, there's only division. There's no multiplication. Now we're going to addition and subtraction inside the exponent. So we had to work on that first. And so now we're just going to add those two. And we get 0.0536. Now we can finish the exponent by taking the square root of that. And we get 0.2315. And then we can finally multiply it by 4.87, our pulled standard deviation, and we'll get 1.274 as our final answer. So that's our standard error for the difference between the sample means.